So the topic of this video is the Fibonacci sequence. It is pretty much each term is the summation of the two terms before it, and we are group 6. The Fibonacci sequence can be seen in nature with various different types of plants, ranging from ferns to pine cones. There are other things like cyclones and eggs that also have it. So the area where Fibonacci can be seen the most is probably in plants, with the growth of branches in a tree spreading out in the Fibonacci sequence, or the distribution of petals on a flower being in the golden ratio. So the Fibonacci sequence can also be represented as a spiral, which is also seen a lot in nature. So when animals reproduce, they reproduce in numbers of the Fibonacci sequence.
Although the sequence was named after a mathematician, Leonardo of Pisa, better known as Fibonacci, it wasn't the first time the world had heard of its significant impact on mathematics. As the 13th century began, Europe started to awaken from the Dark Ages and move into the Renaissance. As its stifling effects of the Dark Ages began to be replaced by a growing interest in the scientific world, artists, scholars, architects and scientists and mathematicians all began making revolutionary discoveries and advancing its knowledge. More than 1,000 years before Fibonacci wrote his Libre Abici, Indian scholars interpreted the sequence with reference to Sanskrit poetry. Fibonacci numbers are the answer to the particular counting problem which arises in the context of Sanskrit metrics and was studied by early Sanskrit poets. This also was the first known appearance of Fibonacci numbers in the world's literature. Before the Han Dynasty, the Chinese people recognized nature's patterns. Moving through the ages to the Renaissance era, the golden ratio, or divine proportion, was utilized by artists particularly in paintings of religious significance. In music, many composers used the Fibonacci sequence unconsciously. One of the earlier composers identified as using the sequence was Frédéric Chopin. This is the piece you are listening to in the background.
Many of the uses of this are a direct result of some specific ratios which can be derived from the sequence. The most well-known of these is the golden ratio, which can be found by taking the nth term and dividing it by the next. This ratio is approximately equal to 0.618. The golden ratio is often found in architecture due to its inherent beauty, and most notably in the Greek Parthenon. Another use is in stock trading, where it is possible to help in making predictions on trends. These predictions use several more Fibonacci ratios. These ratios are the 0.382 ratio, from taking the Fibonacci number and dividing it by the number 2 places higher. Next is the 0.236 ratio, from a number divided by 3 places higher. By taking the high and the low swing, we can divide the area using these Fibonacci ratios. At these points in the market, there is a high probability that they will either receive support or resistance, allowing traders to predict patterns and invest appropriately.
Now, we are going to find this ratio. As n tends towards infinity, this statement is true. We know that a Fibonacci number is equal to the two numbers preceding it, so by replacing fn by fn minus 1 plus fn minus 2, we get the following equation, which can be simplified by reducing the fraction. Now, fn minus 1 and fn minus 2 is the ratio we are trying to find, so let's assign it a character phi. By substituting this into the equation, we get 1 plus 1 on phi equals phi. This can be written in the form of a quadratic, and by using the quadratic formula, we can see that phi is equal to 1 plus or minus root 5 on 2. By taking the positive version of this, we see one of the definitions for the golden ratio. Another interesting set of numbers are the Lucas numbers, which have this formula for the nth number. These numbers follow the same rule as the Fibonacci numbers, but start with 2, then 1. From the formula, we can see that as n gets large, this approaches 0. Therefore, the nth Lucas number is the golden ratio to the nth power. As we have explored in this video, the Fibonacci numbers have many applications and roles in our world, and are a pattern found in nature that have many fascinating properties on paper. Thank you for watching, and we hope you have gained a further appreciation for the sequence starting with 1, 1.